Alright, I finished this project. I actually made all 7 modules, if you can count them. Let's see, 1, 2, 3, 4, 5, 6, 7. There are 7. 1 ohms, 10 ohms, 100 ohms, 1 kilo, 10 kilo, 100 kilo, and 1 mega. And they are all made. Actually, it took me about an hour, sometimes an hour and a half if I was very tired or bored, as fact, to build only one module. 1 hour, 1 hour and a half for one module. But I did it at the end. I did 3 in the same time, and it took me like 1 hour and a half, probably 2 hours for all 3, I think, if I remember right. But pretty much it's like that. It's quite fast to make it this way. But like this other model that I'm having here is the same issue, but here is a bit more easy to make mistakes. So I have to make myself a mentality how to use it, and I try it a little bit right now. Here is a simple, very simple test. As you can see, this is 5 volts. There, 5 volts, and this is a very basic setup. What I'm having here, it's only one single LED without any kind of protection. It's naked in the sun right here. The only thing that is the protection that is having from the high current, high voltage is this box that I'm having here, and that's it. And if something happens like this, you see, if a short, if by mistake you make everything on 0, pretty much you link these 2 wires between them, and you make a 0. You see, your LED is burned. Thanks God, thanks God, these LEDs are supporting a little bit of 5 volts. I'm not sure if they are made to resist to continuous 5 volts, but for short burst, like I just did here, it's kind of fine. But every LED on this earth, they should be protected with some sort of resistor. And this is what I'm having here. Right now it's set 1000 at 10 kilo. This is 10 kilo. And if you press, like I said earlier, it's very easy to make mistakes. This is a bit hard to make mistakes because sometimes you have the intention to put it to 0, but until you drag it from here and put it there, it's taking some time and your brain is kind of remembering, wait a minute, maybe you are making a mistake putting them all to 0 there and making a short. But here, it's just a press of a button, you see? Bang, it's burned, you know? In my case, this LED is quite, strong, but this is having absolutely no chance. Absolutely no chance for mistakes. Very short burst and is gone. Is no LED. And that's a very, very big problem. Very big problem. I don't like mistakes, and usually I do forget. And another thing, I was thinking about it, about this thing while I was building this. I was thinking on this, and usually here is the 0 on the top where I have these blue jumpers. You see, on the top is 0, 0, 0, and then 1, 2, 3 to 9 here. Usually, I mean, it's logic to think that 0 resistance it means a short. Logic, right? It's very logic. So 0 resistance, everything on 0 it means, or here as well, everything on 0 is a short, dead short. It's logic, but it's not intuitive. And we humans, at least I myself, I'm a very, very intuitive person. I rely on intuitivity in general when I'm building stuff. And for me, 0, 0 is safe. For some reason, I cannot explain it, but when I'm going to 0, it's like going to safe mode. In my brain, I have to switch this weird analogy that I'm having, that 0 is safe, 0 is dangerous, is boo-boo. 0 is death. That's to whatever I'm testing there. So to avoid 0, 0, 0 while having it in test, another mentality about it, this is another idea, is to actually unplug this motherfucker from here, switch it to whatever value I want to switch it, and then unplug it back. But this is so shitty to do it like that. But it should be the proper way to do it, because you have, if you are making mistakes, if you are making everything on 0, dead short, meaning 0 resistance, and dead short, you are not affecting anything by plugging it out. But while doing it in the circuit there, set it to 10 kilo there, doing it, so this is the proper way, taking it out. But doing it in the circuit, it's quite risky, quite risky. I find myself making a lot of mistakes, pushing the buttons here, even thinking, having the idea that I will make mistakes, knowing that I will make mistakes, and being very, very careful. I still did mistakes and reset it to 0, 0. How? This is how. When that's why I'm saying it's a bit more complicated when it's in circuit, but it's possible to do it. If I want to lower it down to 1 kilo, I'm leaving the 10 kilo on and pressing the 1 kilo here, and taking out the 10 kilo. And now it is on 1 kilo, 1000. So, but if I want to switch back to 10 kilo, I find myself pressing this to 0 and then to 10 kilo. And if I'm resetting here and resetting everything to dead short, sayonara LED, goodbye. That's a very, very big problem. I don't like it. I don't like this problem at all. I like the device is having a lot of this is better, way more better than this, because it's easier, it's nicer to make combinations, and it's nice. It's way more nice to do it like this. And I don't know if it's not really showing the intensity quite right, no? A 2 at 1. Yeah, it is. So you see, you can make combinations. This is almost like 2. You see, the intensity is quite 19. I'm not sure if you can see it. 19. I want to keep some shadow here. Like this. So 19. This is 10 kilo, and this is 19 kilo, which is, it means 20 kilo almost. And see the intensity lowered a little bit because it's double, and like this. And now if I'm going to 20, so you can make combinations, and you can get absolutely every value, which is, I'm very happy with this design, using these boxes. Resistor box for me it's called, and it's way more nicer to switch the values than here. Here is a pain in my butt, and I don't like it. And I can still make the same mistakes that I'm doing it here, but here I'm making the mistakes way more faster and way more brainless without thinking, and I can fuck up something. So the proper way is to disable it from there, or make a switch somewhere, you know, even having it in the circuit like this, to have a switch to interrupt everything and make your thing. All of this, I can show it into the resistance meter here, and I actually used not this, guys. I have to take them out again to show you. I put them good digit here. Okay, so I have these guys here, and yeah, they have clips, and they also have this you see, screwing thing. Very practical, very practical. I really like them, and I use them in very special occasions. Not they are practically brand new, and I have them for a couple of years, and I'm only using them in very special situations. And I'm taking out these guys here, and moving them aside, putting this on, this and this, and actually measuring the thing, because that's what I want to show you. Doesn't matter, this is not having polarity. Resistors don't have polarity. So let me, right now is not in power. This is, yeah, I have some problems. It's not perfect in any way. I checked and rechecked. I tried to put a bypass resistor somewhere. This is how it's looking, by the way. You see how they are all on this side. Exception this guy here that I built it first, but it's still good enough. I mean, even if it was a mistake, how I did it, then I correct my mistake, and everything else is quite good. I linked a wire between them to have a common thing, and that's it. This is a reminder. So common is separated. You see, 0 to common and 0 separated. So this is the links. This is how the links are going from 0 to common. So from this 0 here to common there, and from this 0 here to this common that is here, and from this 0 to common there, and so on. Okay, let's see. The higher values here are working brilliantly. The last 4, including the 100 ohms. Yeah, you must remember the order a little bit. So this is times 1 ohms times 10 ohms times 100 and so on. So, but the small values, specifically the 1 ohm, why I showed you how it's linked here, because I did test everything. I tried to bypass it. I tried to find a solution, and I couldn't find. If I'm opening this will show me 1.2. Right now it's showing me 0.8, but usually it's showing me 1.2 ohms when it's on absolute 0, on 0 short. But it is showing me, let me switch it one like this. You see 1.2, 1.3. I believe the contactors inside these things are all summed up through, from here to here, are giving me this value of 1.2, 1.3 ohms. And not these wires. And not these wires, because why I'm so sure, when I had only 3 of them, I was having like 0.2, like that, 0.2 ohms. And it was negligible. I really didn't account it. And when I was numbering here from 1, I did a test with 3 of them to find a solution how to link them between them, because I didn't want to repeat the history to make the same mistake linking them all, and then realizing that it's stupid and it's not working. So I did a test with everything laid down like that, very comfortable to work, not stacked like this. And I did figure out this proper way how to link it. But when I was testing them, I was getting 1 ohm here. When I'm pressing for 1 ohm, I was getting 1 ohm, only 3 of them. But here, when they are all stacked together, all the contactors they have there, for some reason, I'm getting plus 1.2 actually, per total for every whatever I'm doing, doesn't matter. So that's a big, it's not a big problem. It's not really a big problem. But if I am, I don't know, if I have to really tweak something that is requiring 1 ohm, I doubt it. I doubt it. All that I did here, I built it exactly as it is in the commercial version. This one as well, I tried my best to make it as in the commercial version, but it's way too much work. Comparative with 1 hour making 1 module, this is taking me 1 day or half a day if I'm stressing myself, and I don't want to stress myself to make the other 3. Maybe in time. But it really, right now I'm testing this idea of resistor box. Usually, how I'm doing things, again, I'm repeating myself. I'm going there, taking one of that trays out, and taking out 1 single box of resistors, and opening and taking out the resistor and plug it in here. I have the most usual values, the most used values, 1 kilo and 10 kilo here in this little casserole, this little round box that I'm having here. Very quick, for testing here, especially here on the breadboard. And I do a lot of tests usually, and I think this is way more quicker than my usual way of doing it. That's why I was so curious about its functionality and the idea of it. It appealed to me. It is a very good idea, but I really don't like it in the circuit. When it is in the circuit, it's just killing everything. So back to the problem here. I'm having 1 ohm difference on one. And 1 is on 0 is 1.2. For some reason it's fluctuating. Sometimes it's 2. I even get some 3. And it's definitely, I am very, very sure, it's definitely something inside all of them. Cumulative, it's accumulating the value. 0.2 here, and I have 7 of them. I don't know, and it's getting me this value, which is fluctuating for some reason. And it's not these wires at all, and it's not this long wires either. Like I said, I did test it with 3 of them, and it worked brilliantly, absolutely fine. And I was sure I will not have any problems, but yeah, shit. He said, fuck you, fuck you. And yeah, it's not really a big problem. Now, when I'm switching to 10 ohms, it's actually almost 11 because of that error that I'm having there, everywhere. The cumulative error, actually. Go down, motherfucker. I guess. I have to reset it from there somehow. So let's do it again. So this is 1.2. Let's count in 10 ohms times 10 ohms, 20, 30 ohms, 40 ohms, 50, 60, 70, 80, 90 ohms. So yeah, these very low values that I'm having here for some reason are fluctuating, but it's 1.2 usually. And yeah, it is getting higher for some reason. I have no idea. It's the configuration that the model that I'm having here is not perfect. If I'm going into the hundreds, the times 100 ohms is brilliant. Starting with 100 ohms up, excelente. So making abstractions of this very unused, really, I don't use this very low values, but I included them there because the commercial versions that I've seen, they have them. Yeah, I didn't have any problems here because I didn't have those these very small values. I wonder if it will do the same, if it will have the same issue. But here the link is very small here, and it's a direct link. It's not a switchable link that I'm having like here. Probably it will be better. I will have to test it, but I don't. Yeah, I remember I didn't have any problems on this, but yeah, I don't have the value, those values. So right now, what 100 ohms I'm starting from here pretty much what I'm having here, and starting 100 ohms plus 10, 110, and plus 1, 111, and it's flickering like an idiot. It shouldn't flicker. Also the multimeter at very small values, the multimeter itself is, well, it is calibrated. I'm using it for 20 years probably. I'm having it, and it's my main multimeter, the one that I'm using it the most reliable, the most trusty, DT9205A. It's the best multimeter, better than anything on this world. Trust me on this. It's very well calibrated, motherfuckers. It's a motherfucker. But for some reason, for small, very small values, and also very high values, like hundreds or tens of mega ohms, it's having quite a bit of gaps in reading, But for the middle range here, 1 kilo, 20, 100 kilo, it's perfect. It's perfect. So we have to take in account the multimeter itself when I'm dealing with these small values. So 112, and this is at 1 kilo you will see brilliantly right on the spot because I'm not having this very small problem there. So 2, 3, 4, 5. You see 116. This is pretty nice. I really like it. And you can combine everything, like I said, 20, 30, 40, 50, and so on. You get it. Okay. And 100. And if I'm not getting the right value, I can tweak it from here. But if it's in circuit and I don't measure it with the multimeter, well, I don't know what is the tolerance that I'm getting. Sometimes it will be 98, sometimes 102. So it will be a little bit of margins of error. So yeah, the same goes for 100 is going up, and 1 kilo. 1 kilo I don't. So I'm getting out of the limit here. I have to switch here to 2 kilo. Actually higher than 2 kilo to count. But right now I am at 2 kilo here, and I'm counting the hundreds of ohms to see that everything is nice. So but here is losing the last digits, and because of you see, it's kind of but not really. I'm not having the best of the best, probably multimeter, or the multimeter is the best of the best, and this is funky. But I doubt it. They are both, both having problems, and you have to deal with it. When I said that it will have the when I said it will be right on the spot on 1 kilo. Probably this is when I said 120, but I have to actually tweak it. I think it gives me some very good results on 1 kilo, 2, 3, like this. So 1.3, 2, 1 and 1. You see 1 kilo, but I have to tweak it here to lower it a little bit. Probably the multimeter doesn't read it perfectly. So 2, 3, 4, 5, 6, 7, 8, 9, 0 again. Yeah, on 1 kilo and 10 kilo, I'm quite happy, and even 100 of ohms here, pretty good. And also it's going up to 1 mega, so I have to put it on 20 mega there. Let me go back. This doesn't matter here anymore. And when I'm switching here, let me put it like this to actually read 1 there. Even if it's, let's see if this will help, probably. Like that. This will help a little bit to actually see the number. And this is 1 mega. So 1 mega, 2 mega, you see, 3. For some reason, it's like having a capacitor there that is raising up and is raising the value. Let me raise here as well, because that is quite low. 4. This is 4 mega, 5 mega, 6 mega. It's calculating something. I don't know why, what, or why. 6, 7. Come on, motherfucker. Come on, calculate faster. 8. Calculate faster. 8. Yeah, it's quite on the very bottom, very margin. 9. And for some reason it stopped. Why? It shouldn't. It's probably I touched something. What? What? It should tell me that is 9 or 10. What? Here is 9. 8 should show me it's 8. 9. Well, for some reason, yeah, probably 8 mega and 9 mega. It should not. Yeah, it's fucked up a little bit. I know I'm having some fucked up problems in readings in some areas, but yeah. So that's it. What is the most impressive thing is that I can combine the numbers, the values, the actual values of the resistors, and I can get all the values that I want, and very quickly, in a very quickly fashion, comparative with going there, taking out, choosing, putting, and taking it out, switching with another one, and it's not really fun. And this is way more faster, like plugging it out, plugging it in. The problem is that you have to be very, very careful. I have to be very, very careful. So this is problem. This will be burned like shit if I'm making mistakes. So if I'm putting it at 100 resistance right here, plugging it in, good enough. All right. Let's see at 1 kilo here. 1 kilo. I really have to put a switch. Yeah, I will add a switch off. The switch off. So 1 kilo. Let's see 500 ohms. Very, very nice. Very nice. So this is practical usage. What I'm doing here. Actually, I can put it 6, 7, but be careful not to get on the 0. 5, 4, 3, 2. I am in the ballpark. So 10, 50. Those 250. Now I can go to 0 here. So now I'm having 50 ohms. 50 ohms, and it's very, very bright. 60, 70. It's very good that it's not resetting to 0 when I'm switching between them, and it's actually making absolutely no contact at all. You see, when I'm between the numbers, that's very good. Because if this was resetting all to 0, 0, 0 to dead short, I was shorting the shit out of it, and it was long gone. So this is 80, but it's not good when I'm in the margin, very close to 0. It's very dangerous to do a stupid mistake, and I'm taking it out to switch to something else, and reset it. And but if I'm in the middle, I can play around. I can play around if it's in the middle, around 5, 6, 7, 4, 3, somewhere there in that range. 3 to 7 in that range I can play. But if I'm too close to 0, I know I will fuck it up. Even if I am thinking about it, I still will fuck it up, because sometimes my fingers go where I don't want them to go. Not really, but sometimes it's like that. I'm making stupid mistakes like everybody else. So this is how you are actually using it. I had to discover these things myself. I had to discover all this, how to link everything that I'm having here. Nobody told me. I had to play and to discover it. And yeah, I also, the next stage in this process is to add a box to protect everything that I'm having here. And it will most probably it will be a metal box. But before I will make the metal box, I'm thinking to put a cardboard. To make a cardboard box first, and on top of that cardboard box I will put the metal box. Why? The simple motive is to protect the plastic, not to scratch it with the metal box. The metal box will scratch the plastic, and I also want it to be press fit, so I will have to drag it out and push it in quite strong. And if I'm doing it like this, not to fall by itself, the box, and being press fit, it's very elegant, very simple, and it's elegant. It's just elegant, and it's good enough. And also to drag 2 wires from somewhere, either from here and here, or only from here, 2 wires from a side. I didn't think yet on this problem. And probably a switch, safe and risky, risky and safe a switch somewhere. I'm not sure. I'm not sure if I will add it, but since I am building it myself, I can invent and I can add or take out whatever I want. I was thinking adding tens of mega. The commercial versions, and when I'm saying commercial versions, I'm referring to this. They don't go to tens of mega. But I am thinking to add tens of mega as well. 1 ohms, 10 ohms, very extremely rarely I'm using them. Nah, not really. And tens of ohms also extremely rarely, almost never. But almost never 1 mega ohms times 1 mega ohms. 100 of kilos and 100 of ohms in this range here. Exactly what I'm having here. Exactly what I'm having here. Here I'm having the most used values, and I'm having them all of them here. But here I have more values than here, and it's smaller. You see, it's smaller, more compact. The size, well, it's a bit higher, the double higher. But yeah, I like it. I like it. I like it very much. The only it is having some problems, like I enumerate them already, specify them already. But even with these problems, I believe I can make use of it quite good. And in time, of course, if this will prove good enough to use it all the time, to use it in general experimentation, I'm thinking to make 2 of them. So to have usually when I buy this, it was 10 of them like this in one package. Now I checked it recently. I think I paid like $2 on 10 of them, $2 or $3, 2.5 or something. Yeah, plus transport, probably $3, $3 and something dollars plus transport. But it's, and I didn't think of this project at all. I have them for 1 or 2 years. I have them for some time, and I just store them. And I thought, well, I will use them someday. Someday their time will come. And I was thinking I will use 1 or 2 or 3, maybe for some reason, whatever, in general electronics that I'm having to count something. But here in this situation, I'm using them almost all of them. So that's interesting. That's interesting, you know. Yeah. So that's the plan, to make the case. Maybe a switch for safety and risky and safety. You know, like a switch here somewhere. I'm not sure. I'm not sure if I will even add the switch, but it's an idea. You know, or a jumper, like here, chaka. Or a jumper or a switch. You know, to yeah, it's looking very retro and very fancy. I really like it. And yeah, another thing, how much it took me to build it. I believe around 3 days, probably. And this thing probably around 4 days. And yeah, so in total around 6 days. But not counting the hours. If I'm counting the hours, only the hours, without breaks, without charging up my spirit and my, you know, only in hours, probably, I don't know, 60 probably hours, probably 50 hours of work, continuous, like, but you cannot do it like non-stop. You know, you have to take breaks, and it's the normal civilized way not to get crazy. We are not in fascism, you know. Even if we are not in fascism, we are in capitalism. In fascism, forced labor, that everybody knows about it, and they were putting normal people like me and you work for probably 18 hours per day, work continuously from start to finish, and with 5-minute breaks to take a shit and eat something while you are taking the shit, so probably 18 hours per day full work and 6 hours sleep. That was the camp regime. I'm not working like that, but it is quite close. I do stay in work sometimes like 6-8 hours per day, but not really all the time. I do take breaks, a lot of them, and I am ashamed I cannot work longer times, but well, it's how I can. The battery is, I cannot think anymore, and I do have to think on this stuff. So yes, thank you very much for watching. Thank you very much for liking. Leave a like, motherfucker. Don't be a motherfucker and leave a like. Thank you very much for watching. I hope you like it, and I believe we will see each other. Well, you will see me next time when I will make most probably. I don't promise, but probably I will. I'm inclined towards adding a protection of some sort, and why not probably to this one as well, like a box that is opening all around and is folding beneath it. It's how I was thinking, and then folding it back and protecting everything like a box of some kind. I'm not really sure if I will add the boxes. Probably I will leave them as they are and throw them somewhere. But if I will do the boxes, I will make another special movie just for this little detail that I'm having there. So yeah, thank you very much for watching. Thank you very much for everything, and see you next time. Yeah. Oh yeah, Q12 is the best. Right, I hope you liked it. Bye bye from Romania, from Q12, your favorite artist electronics. Bye bye.